Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We looked at how we solve a system of linear equations if you have two equations in two unknowns using the method of elimination and the method of substitution. And then we said we can do also graphing. But before we do solve a system of linear equations using graphing, let's see why do we call that linear equation. So today we are going to use only one equation and see how we can plot that. So if I have a straight line can be fully determined if I know about it two things. You ask me what two things. It can be, for example, the coordinates of 2 points on the line, or a point and what we call a slope, and we see what we mean by that, or the slope and a specific point which we call the y-intercept, or even the x-intercept and the y-intercept. So we have multiple ways of defining the same line. So we look at the same line and we can see it from different perspectives. So let's write an equation. Let's say, for example, I have y equals 2x minus 4. And you say, but this is only one equation and two unknowns. So can I solve? No, you cannot solve. In fact, when you have only one line or one curve and I ask you what is the solution, I mean, what is the value of x that makes y 0? I know in the beginning it may be a little confusing, but if I want to plot, we'll talk about that later, but I will get a line that looks like that. And I can find these 2 points. This point is 0 and -4, and this point is 2 and 0, and you can check to see that they both fall on the line. So I can fully determine the line if you give me these 2 points, or if you give me 1 point and the slope will, so what do we mean by slope? Slope is, we call it the rate of change, or for now I can say it's the change in y over the change in x. Or in plain English, how does the y value increase or decrease, but we can define it in terms of increase. For a unit increase of x, again, we want to write it in English, so we say if we increase the value of x by 1. Okay. How does the y increase? Every time I change y or I increase y by, I increase x by 1. Of course, this, we call that the x-axis, and we call that the y-axis. Okay, so these are my two axes. Later, you'll place the arrow only on the positive side of x or y, but you are used to using two arrows, that's fine. Okay. How do I know the change in y to the change in x? Originally, or in the beginning, they tell you form a table of x and y values and pick any value for x. Let's say x is 0. So if x is 0, the right-hand side would be 0 minus 4 is -4, so y would be -4. And then I make x is 1. 2 times 1 is 2, minus 4 is negative 2, and negative 2, uh, I'm sorry. I said x is 1. So if x is 1, 2 times x is 2, minus 4 is negative 2. I wrote the negative 2. I wrote the answer instead of the value. So you see, I increased x by 1 and y increased by 2. So I say the slope in y is the change in y, which it increased by 2, divided by the change in x, which I made it easy by making that 1. So I get a 2. If I make x is 2, 2 times 2 is 4, minus 4 is 0, so I get 0. Again, this increases by 1, this increases by 2. So I don't need to tell you that if I make this 3, that would be 2. It increases by 2. If I make it 4, it would be 4. If I make it 5, it would be 6. So every time I go by 1, this goes by 2. It's a constant increase because it's a straight line. So every time I move 1, I go up 2. 1, I go up 2. 1, I go up 2. Because if sometimes I add 1, if I increase 1, I get 2, then I increase 1 and I get, for example, 6, and then I increase 1, I get something else, it means there is a curvature. But if it's a straight line, I definitely will have the same amount of increase every time I increase x by 1. So that's why we call that a linear. There is no curvature in it. So that's why it's called a linear equation. So if I see an equation that has x without a power, without a square root, without sign, without e to the x, without natural log, just x by itself, and y by itself, then it's a straight line, and it's a linear equation. So now we defined the slope. We see that if I have a horizontal line, every time I increase x, y stays the same. I increase x again, y stays the same. So the change in y would be 0 divided by whatever change in x. If you increase x by 1 or by 10 or by a million, it still be 0. And 0 divided by anything is 0. So the slope of horizontal line is 0. If the line is going from left to right upward, it will have a positive slope. And if the y decreases, every time I go from left to right, the y goes down, or if I go from right to left, it goes up, so backwards, the slope is negative. So this is a negative, very high negative slope. And then it's less negative, less negative, less negative. It's 0, it's positive, 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 more positive, until if you make it vertical, then the slope is undetermined. Because without changing x, y goes to infinity. It's impossible. X doesn't even increase. X is 0. And when you divide something by 0, you get an undetermined quantity. So just by looking, if I see a line, I see slope is 0. I don't need to calculate. I don't know what it is, but it's positive. And I don't know what it is, it's negative. It turns out that if I have y by itself, just y, not 2y, not 3y, not 1/2 y, just y, then and I have y on the left side and x on the right-hand side, the coefficient of x is the slope. And that's what tells me how much I go up or down. I go up if it's positive, I go down if it's negative every time x increases by 1. X increases by 1, this would increase by 2, so it would be 1 and -2 instead of -4. It would go up by 1. I go 1 and 2. So that would be 2 and 0. I go from -4 to -2, from -2 to 0, and that's the 2 and 0. This would be called the solution of this line, meaning where it crosses the y-axis. We are not going to use this term for now, but we are more interested in that guy, the -4. Oh, -4 is here. It's the y coordinate of that point. And this point, or this value, which is the -4, is called the y-intercept. It's where does the line cross the y-axis. Okay, so now we usually will see it written generally written as y equals mx plus b. M here is the slope, b is the y-intercept. And that's a form that we call slope-intercept form. Okay, but I could have as well give you these 2 points, and I say I have a line that passes through points 3 and 2 and 5 and 6. Find its equation. So a line passes through points A, 3 and 2, and B, I said 5 and 6. Find its equation. I know its equation is y equals 2x minus 4. We did that, but how do I solve it? I solve it by finding m and the y-intercept, right? So I say m equals change in y over change in x. Well, the change in y going from A to B or from B to A, it doesn't matter. It really doesn't matter. Usually we will say, okay, I'm going from A to B. So how much did the y increase and how much did the x increase or decrease? But I can go from B to A. So I can say if I start here and end here, the y dropped from 6 to 2. So it decreased by 4, right? It's 2 minus 6 over 3 minus 5. Notice I started with the 6, so I start with the 5. And then I end with the 2, so I end with the 3. So the y goes, or which is the same as saying it's going from 2 to 6, so y2, if I call this point x1, y1, and this is x2, y2, we can say it's y2 minus y1 over x2 minus x1. That's what you learn in school. But I can as well say it's y1 minus y2 over x1 minus x2. As long as I keep it going from the same point to the same other point, I'm fine. If I do it the first one, I say it's -4 divided by -2. And if I do it the second way, I say it's 4 divided by 2. And in both cases, I get 2. Why do I tell you, you don't have to say y2 minus y1. I can say y1 minus y2. Because if I switch these 2 points, I say A is 5 and 6, and B is 3 and 2. If you do y2 minus y1 over x2 minus x1, both would be negative. I know that negative divided by negative is positive, but it's much easier if I say, if they were switched, I say y2 minus y1 over x2 minus x1, and I will get 6 minus 2 over 5 minus 3. So I get positive numbers. You see that? Okay. In math, when we use subscripts like 1, that defines numbers. So I know x1 and y1. In this case, it's 3 and 2, but for other problems, they may give you, say, 7 and -4. That would be x1 and y1. The other point, I call it x2, y2, because it's a different point. But what if I pick a generic point? So I have a line. I'm going to draw a line. I don't know its slope. I don't know anything in it, but I'm going to draw it like that. And I say I have a point. It doesn't have to be to scale. It doesn't have even to make sense. So maybe this would be higher than that. I don't care, because I'm using that just as a vehicle to solve. So I'm going to say this is point A, which is 3 and 2. And this is B, which is 5 and 6. And I want to find the equation of the line. So we found the slope. We found the slope by making a triangle, by completing a triangle, and say this height, which is the change in y, is 4, 6 minus 2, and that width is the change in x, 5 minus 3, so the slope is 2. I know the slope is 2, meaning every time I move 1 to the right, I go up 2, or if I move 1 to the left, I go down 2. Okay? But now I need to find the equation. Remember, we said if I use subscript, it means I know these numbers. But what if I don't use subscripts? I pick a point here. How can I give coordinates of that point if it's just a generic point? It's not a specific one. It's just the general one. I'm going to call it x and y. Okay? I don't want you to memorize. I want you to understand. So I use these 2 points to find the slope. Now I need to find the equation that has x and y. So I create a point and I call it x and y. Okay? Now, someone would say, oh, do you see the segment CB or BC or even AC or CA? This segment, whichever segment you pick, has the same slope as the line because it's part of the line. So I can go back and write the same equation. I say m equals change in y, but the change in y here, if I'm going from A to C, would be y minus 2. So a letter minus a number? Yes. Over x minus 3. And that we found that it's 2. Oh, so now I can cross multiply, and meaning I multiply both sides by x minus 3. These two would cancel, and the left-hand side would be y minus 2. The right-hand side, I'm going to distribute the 2, so I get 2x minus 6. And then I'm going to add 2 to both sides. So I get y equals 2x minus 4. Wait a second. Isn't that the equation we had? Yeah, y equals 2x minus 4. So if I'm given 2 points, I can use them to find the slope. And then I'm going to pick an artificial point and say, okay, the slope of this segment, or that segment for that matter, it doesn't make any difference. I could have picked CB and it would be the same. I will end up with the same equation, has the same slope. So I equate the slope of this piece to 2. Do you see that what I did here, if I write it with letters, because here we call that x1 and y1, the 3 and the 2. So when I say what I ended up having here after I multiplied by x minus 3 was y minus 2. But y minus 2 is y minus y1 or y2, but usually in math, we call it y sub 0, assuming we only have 1 point. So instead of saying x1 and y1, we say x0 and y0. Really, this number doesn't make any difference. Equals the slope, which is 2, multiplied by x minus x0, which is 3. And this is how you see it in your book. And it says, we call that the point slope form. Here is the point, x0, y0, and here is the slope. But I don't need to memorize it. I found the slope and then say the slope of this piece is the same as the slope of the line, and I get this equation. Okay? So you would say, so why did you do it like in 2 steps? Couldn't I just say that this slope 6 minus 2, so I can call it y2 minus y1 over x2 minus x1 equals the slope, right? Which also equals y, say y, which is this y, minus y1 over x minus x1. In just one step? Yes, I could. So I would have said 6 minus 2 over 5 minus 3, I don't have to say equals m, equals y minus 2 over x minus 3. That's exactly what we did. So we can write it in one step. The slope of the line joining point x1, y1 and x2, y2 is the same as the slope of the segment AC, which is y minus y0 or y1 for that case over x minus x1. And again, here you will get 2 equals y minus 2 over x minus 3, which we had exactly here. So instead of doing it on 2 steps, we could have done it on a single step. But that's how we find the equation of a line. If we tell you a line that has a slope equals 2 and a y-intercept equals -4, which we had in our line. So instead of drawing the line, I will tell you I have a line that has a slope of 2 and a y-intercept of -4. I know the equation is y equals mx plus b. This is the slope, we said. This is the y-intercept. So I say y equals 2 times x, and the y-intercept is -4, so -4, and it would be so easy. Sometimes we can give you this equation. I'm going to subtract 2x from both sides, meaning I'm going to make the variables on the left-hand side -2x plus y equals -4. And I tell you, draw this line. You say, oh, I'm going to add 2x to both sides and get this, and then find the slope, and then find the y-intercept. No, you don't need to do that. What do you mean? I mean, you don't. you can find what we are going to call the x-intercept, which is that distance, which is 2. This is 2. The x-intercept, which I told you may be described as the solution later. So the x-intercept and the y-intercept. The x-intercept is the right-hand side divided by the coefficient of x. And the y-intercept is the right-hand side divided by the coefficient of y. -4 divided by -2 is 2. And -4 divided by 1 is -4. So I have this. I have the x and the y axes. I say the x-intercept is at 2. So this is 2 and 0. And the y-intercept is at -4. So this is 0 and -4. And now I can join these 2 points and plot the line, which you see here. I already found these 2 points, and that's all what I need in a straight line is the coordinates of 2 points. So if I'm given the equation of the line in standard form, which we call that standard form, I have the x and the y on the left and the constants on the right, I can plot the line quite easily. I don't have to make it, because I've seen students always try to make it look like that, y equals mx plus b, and then they draw it. No, you don't have to. You don't have to. Sometimes you can find the x and y intercept quite easily and then plot the line. I think this was a little too long because I wanted you to understand the ways you can get a problem. You can get a problem like that and we tell you to plot it, or we can give you a table and we tell you plot it, or we can give you the equation and some values of x and we tell you find the corresponding y's, then plot it, and so on and so forth. So next time we are going to take few examples of, giving you an equation, and then maybe some problems where we give you a table to complete and find and draw the line. And once we are confident we can do that really easily and quickly, now we can go back to a system of equations. Now we have 2 lines and we ask you, graph them. And what do you do when you graph them? You will see whether they intersect. The point of intersection would be the solution to the system. So what we did yesterday and the day before just yesterday when we were solving, we did it 2 days in a row. We did substitution and elimination. So instead of using substitution or elimination, if I have the equations of the lines, I can plot them as linear, meaning 2 lines. The point of intersection would be the solution. Sometimes I draw the lines and they become parallel, meaning they will never intersect. Yes, that's when you get the no solution case. Remember when I told you x plus y is 10 and x plus y is 11? Yep, that's the case. You have 2 lines that are parallel. They may be parallel like that, or parallel like that, or parallel like that. It doesn't matter. So if they are parallel, there would be no solution. And sometimes I give you the same equation, but it doesn't look. So I say x plus y is 5, and 5x plus 5y is 25, which is the same thing. I just multiply this by 5. So it's the same line on top of each other. So any point along that line is a solution because that's where the two lines, It's just one line. The two lines intersect. They intersect everywhere from negative infinity to plus infinity. You pick any point, it's the same point, right? So any point on the line is a solution, and we have infinitely many solutions. But try as hard as you can never get exactly 2 solutions or exactly 17 solutions or exactly 25 solutions. It's either 1, none, or infinitely many. Okay, I'll stop here and see you next time, where we are going to really see how we plot the graph or graph the lines. Okay, again, as usual, if you have any questions or comments, please don't hesitate to let me know, and I will get back to you as soon as I can. Otherwise, I wish you all the best and hope to see you soon. Bye.